All right. For the last 3 weeks, the team I am in, the recursive searchers, and I have been working on a customer churn predictor. Customer churn predictor has become a significant part of the commercial sector over the last decade. This is because it can predict whether the customer will leave or not, based on a few conditions. For many companies, this predictor is critical and it allows the company to focus on other matters. Our goals were figuring out what features were significant in predicting the churn of a customer and to suggest an action in attempt to improve the retention rate of the customer category. The processes include data exploration, machine learning model training, and aid the companies. Data exploration, we found a data set that fit our needs and then cleaned it by removing columns and converting data. Machine learning training model. Training the data was accomplished by using 80% for training and the other 20% for testing. And finally, the aid the companies. The overall goal for this model is to make it applicable in the real world by being able to support companies. Okay.
Next, this is our tech stack. This basically just goes over all the different libraries we used for the website development. We used HTML, JavaScript, CSS, GitHub, Bootstrap, Flask, all this fun stuff. These were crucial in making our development of the website easy and fast. Next, for our collaborative workspace, we use CoCalc, Zoom, and Discord so we could talk with each other, fix each other's errors, and help each other out. Next, for data analysis, we used Seaborn mostly in our EDA, Python, of course, Plotly, Pandas, NumPy, Matplotlib. We mostly used Plotly in our website, but Seaborn was our main graphing library for our EDA. Next, for machine learning, we used Scalar and XGBoost, SVC, and a bunch of other models. This was so that we could get the most accurate results, and in the end, SVC was the most accurate. Next, we made a prediction here. Basically, you can enter any value, and it'll tell you whether or not the customer will churn or not. You can enter an age. Once we let it load here, it should give us a result. And basically it said the customer's not going to churn. So that's the result it gave us. Next is our EDA, which is the exploratory data analysis. This is one of the most important steps in data science. This helps us better understand the data. It's also important in the machine learning process so that we can figure out which variables are most correlated. Here we created a heat map, which shows the correlation between different values. As you can see from the heat map, everything had pretty much the same correlation, so we didn't have to get rid of many columns, which was good. Next, we created a scatter plot, which shows the correlation between age, balance, and whether or not they were churned. As you can see, after the age around 45, we are starting to get more of a churned result. This pie chart here just shows whether or not the person exited or not. The red represents exited, and no, the red represents non-exited, the blue represents exited. This will be the same thing for the count plots coming up. These count plots, we took 3 that were our best count plots, and we added them here. Blue again represents whether or not they exited, and the red represents exited, blue is non-exited. This 0 here represents male, the 1 represents female. Here, 0 represents that they're not an active member, 1 is that they are. This just shows the correlation between the two. Here, it just shows that, where the person is from, so either France, Spain, or Germany. And finally, in our box plots, it shows us the blue represents the age to whether or not the person exited. The red is balanced to exited. The green is tenure to exited, and the purple is the estimated salary of the person to whether or not they left. Here you can see the first quartile, and the third quartile, the min, the max, all that fun stuff. Aakriti.
Okay, so the next step in our customer churn analysis was machine learning. So we use machine learning to see if the customer would stay with the bank or leave. And based on the results we got, and as you can see here, support vector classification got the highest result with the recall rate of 93%. So here are our services. Here we are working.
Yeah, so here are machine learning models. The first one is XGBoost, which is basically an extension to the gradient boosted decision trees. And it was specifically designed to improve speed and performance. And it provides parallel tree boosting to solve many of the data science problems in a more fast and accurate way. And here are results for the XGBoost and a confusion matrix. And what a confusion matrix is basically a graph that tells us the number of correct and incorrect predictions we have for every class. So in this case, exited or non-exited, and XGBoost performed quite well in this data set. And the next model we used was a random forest classifier, which is similar to a decision tree, but it uses multiple trees to address the issue of overfitting. And here's a confusion matrix for the random forest classifier. It had a lower correlation overall than the other models, but it was still quite accurate.
So decision tree classifier builds branches of if-else statements in a hierarchy, as seen in this visualization, and it develops the data by dividing it based on the data's most important features. And so the confusion matrix, here it shows the results. A support vector classifier uses an algorithm that splits the data given on a border called the hyperplane, as seen on this picture here, and it separates the data into classes. And this is the confusion matrix for support vector classifier. And in terms of the confusion matrix, there's not a lot of correlation, but it performed well in terms of recall rate.
Yeah, so our conclusion, we want to say that we're focusing more on the recall. SMV clearly performed the best on our data set for predicting if customers is going. Yeah, I'm sorry. That if customers is going to churn or not. Also want to mention that we used all the features that we could in the correlation map. Also want to mention that there could be multiple reasons of churn in a customer, like leaving to the competitor, missing functionality, poor customer fit, and etc. And so our next section is so what. In so what section, we just wanted to say like why our product is important, how you can use it. And our product you basically can use just like in a business where you can understand like, oh, if a person is going to leave me or not, depending on depending on your data, right? And then our team section. So first person, of course, is Keshav, our mentor, our teacher. Then is my teammates, Aedan, Aakriti, Matthew, then Eric, then Yoonchul, and then me. Yeah, and then our section is then the next section is just contact section where you can contact camp or maybe even us. Yeah, so thank you guys for listening, and thanks my teammate for doing this project. It was nice to work with you.